Hello, today we're going to be looking at factoring quadratics, and all of the quadratics we're going to factor today are going to have a leading coefficient of 1. Remember, a leading coefficient means the number in front of the leading number, the biggest exponent, is going to be 1. And we're going to look at these in standard form. Now, when we did these diamond problems, we're unfoiling these, is what we're doing. So that is, I'm thinking, what two binomials, when I multiply them, will give me x squared plus 8x plus 15? Well, since I know when I do the first terms, it has to multiply to x squared, so x times x. And that's what will happen in every problem today. Now, I'm going to look at what two numbers multiply to 15 and add to a positive 8. The reason it multiplies to 15, when we do the last term, we know it multiplies to 15. The outside and inside, they add together, they add to get 8. So these are like the diamond problems we did at the beginning of class. So I'm looking at what two numbers multiply to 15 and add to 8. And so now I start looking at what two numbers. So I'm going to start here with the basics, 1 and 15. 1 times 15 is 15, but 1 plus 15 is not 8. So I know that is not the correct way to do that problem. So I do a little guessing and checking is what I'm going to do here. Now I'm going to take a look at what two numbers, what else multiplies to 15 besides 1 and 15? Well, 3 and 5 do. And notice 3 plus 5 is 8, so I get x plus 3, x plus 5. And I'm done with that problem. That's all I got to do. Now, this is my solution. But we can distribute our FOIL to make sure it's correct. That is, when I FOIL, I'll get x squared plus 5x plus 3x plus 15. And notice 5x plus 3x is 8x. And there's my answer, x squared plus 8x plus 15. Now if I take a look at the second problem, now remember, don't write x squared plus 8x plus 15. That's your problem. Your solution was factored form was x plus 3, x plus 5. Now I look at problem number 2. I'm going to do the same thing. X squared minus 9x plus 20. So I'm looking what two numbers multiply to 20 and add to a negative 9. So then I'll get x and x. They multiply to 20. They add to a negative 9. What two numbers do that? Well, in order to multiply to a positive and add to a negative, both of them have to be negative. And now I'll just start guessing and checking, and I'll get negative 5 and negative 4. That's what goes here, x minus 5 times x minus 4. Now if I take a look at the second problem, x squared minus 8x minus 9, in example 5 here. So I'm going to look at two parentheses again, x and x, what multiplies to a negative 9 and adds to a negative 8. Well, this is a little bit more complicated, but not too much more complicated. So I say what multiplies to negative 9 adds to negative 8. Well, since it has to multiply to a negative, one number has to be positive, one number has to be negative. Since it adds to a negative, from what I know about adding integers, is they have to add to a negative number, add to a negative 8. Well, that means a bigger number of this pair has to be negative. So I'll start here with the basics, 1 and negative 9. And notice that. I started with the basic one. Now, if you would have tried 3 and negative 3, you get 0. Don't forget, 1 goes into everything, so don't forget that one's out there. So this one turns to be x plus 1 and x minus 9. Now in the next problem, x squared plus 3x minus 18. Well, that turns out to be two parentheses, x and x, multiplies to a negative 18, adds to a positive 3. And once again, multiplies to a negative, so I know one number has to be positive, one number has to be negative. It adds to a positive, so I know one is positive, one is negative. So I'll try 6 and negative 3. I could have tried 2 and 9. I could have tried 1 and 18, but I decided to try 6 and negative 3, and 6 plus negative 3 is 3. You just do guessing and checking until you get it right. So there we go. X plus 6, x minus 3. We're done with that problem. That's what we got to do in these. Now, this one, on example 9 and 10 of the problems, they're going to just ask you, hey, can this be factored? Plain and simple. They're not saying, hey, factor it. They're saying, can it be factored? Because sometimes you start doing a problem, there's so many different ways you could do the pairs. It might be kind of tough. Well, I'm going to say make your diamond. What multiplies to negative 7 and adds to a positive 6. So once again, I know one number is positive, one number is negative. The bigger number is positive because it has to add to a bigger number. So there was only one way to multiply to 7, and that would be 7 and negative 1. Is 7 plus negative 1 6? Yes, it is. So can it be factored? Yes. You know the factors, x plus 7, x minus 1. Now, what do I do if I get a harder problem than the one I gave you here? What happens if, we got something that has 15 factors? You probably don't want to sit there going through every single pair until you find them. Well, one way you can do that is remember our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this problem, a is 1, b is 6, c is negative 7. Now, I'm not going to actually solve this because it's not an equation. It doesn't equal to anything. What I'm really concerned with is the part we call the discriminant. And the discriminant is the part underneath the square root sign. B squared minus 4ac has to be a perfect square. Well, I'm going to say, in this case, to make it simpler for you, is if the square root of b squared minus 4ac is a whole number, the quadratic can be factored. Well, let's see if that turns out in this case. So if I'm going to do the square root of b squared minus 4ac, that's going to be, b we said was 6, so it'll be 6 squared minus 4 times 1 times negative 7. So then I'll get 36 minus a negative 28. 36 minus a negative 28 is a positive 64. The square root of 64 is 8. That's a whole number, so I know, yes, it can be factored. Now let's take a look at number 10. And once again, I'm going to start here with the diamond if I can. Multiplies to negative 5 and adds to 6. This one isn't so bad because there's only two numbers that multiply to 5, 1 and 5. One of them has to be negative, one has to be positive, and I know the bigger number has to be positive. So the only way there's only one pair that can even be close here. So I get 5 and negative 1. And 5 plus negative 1 is 4, not 6. So this one is not factorable. I can't find a pair. Now, if I take a look here, let's find out, is b squared minus 4ac a whole number? The square root of that is. So b squared is 6 squared minus 4 times 1 times negative 5. So then I'll get 36 plus 20, square root is 56. That is an irrational number because it's between 7 and 8. Because the square root, or 7 squared is 49, 8 squared is 64. It's in between those two numbers, but it's not going to be a whole number. So I know this problem is not factorable. And that's all I do with those. Now, how do I solve by factoring? We're going to combine with what we learned today with what we learned yesterday. And yes, I could solve this by quadratic formula. There's nothing wrong with doing that. So what I'm going to do first off is I'm going to make one side equal to 0, put this quadratic formula, or this quadratic equation in standard form. So I'll get x squared minus 5x minus 24 equals 0. Now I'll try to factor this. What two numbers multiply to a negative 24 and add to a negative 5? So one number is positive, one number is negative. I know the bigger number has to be negative. And I'll think, well, geez, I got a whole bunch of things that multiply to 24, but they have to add, in this case, to a negative 5, or subtract if you think of a positive and a negative. And so I'll say, let's try 2 and negative 12. That adds to a negative 10. So 2 and negative 12 do not work. Okay? I know 1 and 24 aren't going to work, so, here we go. How about 3 and negative 8? That adds to a negative 5. So in other words, I factor this. I get x plus 3 times x minus 8. Now, since they equal to 0, I know x equals negative 3 or x equals positive 8, and I'm done. That's all I got to do in those problems. That is, set it equal to 0, factor it, and then solve that factoring problem just like we did on the assignment from yesterday. And we're done. And that's all we're going to do today with factoring x squared plus bx plus c. That is factoring with a leading coefficient of 1.